Hi class, let's take a look at this problem right here. We have a hypothesis test. Study was done using a treatment group and a placebo group. The results are shown in the table. Assume the two samples are independent, so this means independent treatment will be in effect, and are from normal populations, that's critical. Do not assume the population standard deviations are equal, so that means we will not be pooling the variances. Alpha is 0.1. So we want to basically test the claim, and this is going to be the mu's are equal and the mu's are not equal. So this is a two-tail test. So StatCrunch is going to be my tool of choice to answer this question. So go to Stat, Tstat, two-sample with summary. And now I'm going to type in the values that you see right here. The sample size is 29 for the first group. It is 38 for the second group. The mean is 2.39 for the first group. And it is 2.66 for the second group. And the standard deviation is 0.69 for the first group and 0.67. 0.96 and 0.67. We will not be assuming that the standard deviations are the same. Therefore, we will not be pooling the variances. So leave this clicked off. Make sure that this is set to 0 and this is set to not equal to. And now we're ready to compute. So the test statistic is right here, negative 1.29. And the p-value is located right here, 2022. So 0.202. Okay, so now it's time to make the decision. Since the p-value is bigger than alpha, I will fail to reject the null. So therefore, B and D can be eliminated. Looking at A and C more intently, we see that A is going to be the answer because we failed to reject and there is not sufficient evidence. Now what they want me to do is they want me to construct the confidence interval. So remember that by default, by definition, confidence intervals are two-tail scenarios. Coincidentally, this hypothesis test is also a two-tail scenario. So I can just basically plug in the same values as before, and it will essentially allow me to arrive at the appropriate confidence interval. So give me just a few seconds here to type these in. Okay, again, I will not be pulling the variances, and I want to do a confidence interval here and make sure that since my alpha is 0.1, that means the confidence level will be 0.9. Okay, and since this is a two-tail hypothesis test and confidence intervals are by definition two-tail scenarios, I do not have to make an adjustment on the confidence level to get the equivalent confidence interval to the corresponding hypothesis test result. Hit compute, and here's my result, negative 6202. So negative 620, and then the upper limit is 0.080. Okay, and that's it. Thank you.